So another core part of this is like how we do repetitive things in LabVIEW. Okay, so usually this programming stuff is only we do because we can't do repetitive things continuously. Okay, so that's why these structures are very useful when we design our programs. And one of the structures are like for loops and while loops. Okay, so those loops are used for different repetitions of our programming code. Okay, so there are special kinds of two loops which are used in LabVIEW. Okay, those are called while loop and for loop. Okay, so while loop and for loop are little bit differences, but both are used for repetition of code inside that loop. Okay, you see in a while loop, this while loop is continuously run until some particular condition is met. For example, what we seen in our previous example, like until we supply the true value to that stop button, this while loop still runs continuously. Okay, so that is a difference of while loop. But what in for loop, it is not like it do not require some conditions. Okay, but we give some numbers to that loop, and that code inside that loop runs for that particular numbers of repetitions. For example, here you see I suggested like n is equal to 100, and this code will start running for 100 times. And after when 100 times is finished, this program will stop. So this is how it looks on your block diagram, right? So this is while loop, it looks like on block diagram, and this is for loop, it looks on your block diagram. So in while loop, there are like few things you see. There is the one I you whenever we design. So this is called iteration terminal. Okay, so it will tell you how many cycles it has done, and this red dot is called terminal node of the while loop. So until we supply some value to this, like true, then each while loop will continuously run. Okay, and similarly in for loop, you see there are two terminals. One is counter terminal, uh, and this is iteration terminal. Okay, it also counts the iteration numbers. Means like first loop, it will start from 0, and then it will keep on counting 1, 2, 3, 4, 5, 6. Okay, and here we supply the number of loops we want to execute the code inside there. So this is basic differences from for and while loop. While loop continuously runs until the condition is given to stop, and for loop runs for given particular number of times. Okay, but there is another way of putting the same loops. Okay, and this is called the optional configuration. Okay, so you have while loop and for loop, but there is a one extra thing here. Okay, so you see terminal to exit is changed, means this condition is like run until the value is true. Okay, so before it was like run until value is false. When you supply the value true, it will stop here. Okay, when you supply the value false, it will stop here. Yes. So this is the two different. So to change this to green to red, you just right click on this and you select which option you want to select. Okay, run until or stop until. Okay,
Okay.
yeah, and then the for loop, which was like this before, without any red dot or red terminal, we have this another option for while loop, for loop also. Means it will run normally as for loop runs like 100 times, but if we suppose like we want to terminate that function in between, like I don't want to run it for 100 times and I feel like it is taking long time and I just want to stop it, so we use this kind of for loop. So it is called terminal for loop, and to add the terminal you right click on here and select like which terminal for loop. Okay, then when you select terminal for loop, you will get this button here, right? Then you can supply some conditions to stop, or you can connect some button to stop the for loop at any time. Okay. So this is to take control of for loop. Means if you don't put this, for loop will not stop until you press this red button. Okay. It will keep on running until you the 100 times the loop count is finished. So here are the three different components when you see in the for loop, and this is the while loop. Okay. So for a while loop, they're like this is the button which can be changed to this one. Okay. So when it is like this, you have to supply the true value to stop that while loop. Okay. When it is function like this, they continue if true. Means if you supply the true value to this, the while loop will continue, and if you supply the false value to this, it will stop. Right? And it has the iteration terminal, means it will give you number of count it happens in your while. Okay. Similarly, for loop also has like a few different things. The normal for loop will have like count terminal and iteration terminal. Okay. So when you supply count terminal number, the for loop will run for that particular counts, and the iteration will count from 0 to one number less than the count terminal. Okay. And the another configuration wise, like you can put terminal for loop also. So right click on its edge and say that I want to put a terminal condition. Then this n count terminal will become like this. So there will be red dot, and you will have this particular condition inside the for loop. And then you can supply some condition to stop the for loop at any time. Okay. So for example, you see this is while loop I use, and this is normal condition. Okay. When we count it, and this count is like less than greater than 100, it will give a true value. Okay. If it is true, then it will stop. Right.
Mm-hmm.
So another one is this one. Okay. So here also the same thing. This while loop will run until this value is not false. Okay. You see, it is opposite to this. This will stop if it is true, and this will stop if it is false. Okay. So when this matching is greater than the number to match, okay, it will become false. Okay. And when it becomes false, it will be like stop the while.
Yeah.
This is just example. Okay, you can design this and you can test it how it works. Okay? And this is a for loop, our regular for loop. Okay, so where you supply 100 numbers, so this for loop will
Mm.
run 100 times. Okay, and 100 times it will generate some random numbers, and 100 milliseconds are giving for each loop. Okay, so each loop will run for 1 second and 100 times. Okay, so this for loop will take almost 100 seconds to complete all the calculation inside. So this is a normal for loop. Okay, then this is the next for loop, which is called terminal for loop. So this is the same coding here. Okay, 100 times for 1 second each cycle. Okay, and it will run for 100 seconds. Okay, right. So it will run for 100 times, and each time it will take 1 second to complete. Okay. So it will be like 100 seconds to wait to complete this program, right? So if I want to stop it in between, I use this terminal. Okay. So I right click on its edge and ask like I want to put terminal condition inside this for loop. So it will be appear here. Okay. Then we can condition a stop button to here, so that if I want to stop before 100 seconds, I can click it here and the program will stop. Right. Here is a value and here is a value. Both do the same thing. Right. It also wait for some seconds. It also wait for some milliseconds. Right. So what is the difference between these two delays? This is function name is called wait until next millisecond multiple, right? And this is wait for millisecond. So this function is very accurate. Means like if you give some value to this, it will count to that many milliseconds, and then the next cycle will run. Okay, it monitors like milliseconds counter. Okay, and whatever number you give, it will wait for that much seconds for the next cycle to repeat. Okay, so that is very good for your like some time sensitive application, and it is very used to synchronize the activities like you control the loop rate. But if you don't want like two cycles to run with different time delays, you make both cycles having the same time. So then you use this. This also do the same thing, right? It also allows the program to wait for the next loop. It adds the wait time to your code. Okay, so if your execution code takes like 3 milliseconds and you put 20 milliseconds here, your total wait time in the loop will be like 23 milliseconds. So this is not good when you want to synchronize the two codes together. Okay, so it will be like every time the coding will take longer time or shorter time, the delay time of iteration will be different. So for calculation purpose, you can use this one to just to give a rest to your CPU. But for like data acquisition or some data collection from outside, you use this to synchronize the cycles. Okay. Like there are different structures other than the for loop and while loop. Okay, for loop and while loops are also structures in LabVIEW, but they have the specific functionality. Like for example, the while and for loop both are used for repetition, but there are other than these structures, and there are these many structures which are most commonly used in lab. Okay, one of that was a formula node used to calculate the sequence of expression, and using like our C kind of language. You define some inputs and outputs, and you put some programming lines, and it will calculate and it will output into your uh, output of this formula node. Okay, the flat sequence is another, so which is used for like coding for one after one after one after one. Okay, so this code will never run until this code is finished. So this is to like force your LabVIEW program to do these things before doing the other thing, right? So I don't want to execute the code for until all these three codes are run. So that's why you put this flat sequence structure. Okay? The case structure is there when you have different possibilities of your action and you want to choose one of them. For example, I want to put like this code should run like if I put a true as a logic. Okay, so this code will only run if this button gives a true value to this condition. Okay, and if I give a false, there will be click here and you will have the another case which will give you the code, allow the coding for that particular case. Okay, and there is the event structure. It is very useful when you design for like user input programs, right? So it can access the how you have mouse inside your pen, or you have pressed some keyboards on your mouse, your keypad, or you have some mouse out of your program area, then it will not execute your commands, etc., etc. Okay, so the LabVIEW reads these events, and you can for that event. Okay, and then there is a one more structure. It's called disable diagram structure. Diagram disable structure. Okay, so this one will be used to cover up your code in your block diagram. For example, you have some coding which needs some further modification, but you don't want to execute right now. So you just cover up that code, and the LabVIEW will not check for the errors inside the code. Okay, so this is called disabled diagram structure. Okay. I will explain it little bit more. Okay. So this is a formula node what we describe, right? So it is similar to C on the block diagram, right? So to add some inputs, you just put that formula node, right click on this, and you will have the option to add inputs, and right click on this side, and you have the option to add output. Okay, so you define x and y and something z, and you do calculation as per this thing. Okay, but sometimes it's very necessary to do this type of coding, then we use this particular node. Okay, And there is another one is called structure. As I mentioned that this particular structure is used to force the library to do code execution of code in sequence only. Okay? So the code will never run before the next previous code. Okay? So until this code is run, like code 1, 2, 3, code 4 will never run. Okay? So this structure, it takes a long space in your block diagram. You see, it takes this much long space, and if you want to save the space on your block diagram, you can replace this code. You write the code, and if you want to shrink the code for a small space, you just replace. Right click on this edge and click on here. Okay, this is called replace with stacked sequence. Right. So when you do this code will be like one frame is attached on top of each other. You see here. So there are like 1, 2, 3, 4, and 5 frames, but all are on top of each other now. So it is called 0, 1, 2, 3, 4. Okay. So it will do the same function as it does, only it will save the space for your on your block diagram. Okay. But when you want to understand what is coding behind your program, this structure is always better because you will see in one side what is happening in your coding, right? And there is another case called a case structure, okay? What I mentioned earlier. So in the case structure, there are like three inputs, okay? Three particular points to know about. One is here on the selector label, okay? The so whatever we put input, okay, like case selector here, this one is called case selector. Okay, when we change value for here, the case structure will change label here and the code also from here. Okay, so if you have like cases like 1, 2, 3, 4, 5, then you will have different blocks on this code. Okay, so when you click here and select one, then you will go to that particular block of coding. Okay, so this is we use it to select particular case and execute that particular case. Okay, so you see when we use this case structure, okay, it has many cases inside this, but only one case will execute because of this selection. So even there are five cases. If I select only case number 3, so whatever the code is in case number 3 will execute only, not the other cases. Okay. So this is to have option for us. We design for different options. We code it for different options, and when we select particular option, then only that code will be executed. Okay. So there are different types of case selectors available for this case structure. One is can be used for boolean, one can be used for number, and one can be used for enums. And as I mentioned, the enums are very specific to coding, right? So it is only used for block diagram, and it is useful for that particular case. For example, here you see I use the case selector as a boolean, so it has only two values, right? True or false. Okay. So if I see the cases, there will be only two cases. One is for true case and one is for false case. So I will be have the two types of codes written inside this. One is for true case and one is for false case. Okay. So if I want to have like many cases, for example, if I select number as a case selector, I will have the different cases for different numbers. Okay. So for example, 0, 1, 2, 3, 4, 5, there are cases, and I want to select one particular case, then there will be just that particular case will be executed. For example, if I select 3, then the case number 3 will be executed here. Okay. So this is like giving number to selection label. But when we use enums, it is very easy to understand what coding will be there. For example, I define this enum to have the numbers, but have some text also. Okay, enums are like text and numbers, right? So text will appear here. That case one was like case 0 or case 1 and something like that. Okay, So we can use enums as case selector, a number as case selector, or as a boolean value as a case selector. Okay. So when you have like many cases inside this, it is always possible that you will have some case selection value which is not defined in your case. Okay. So for example, I use a number here, but I only define for like three cases, 1, 2, 3. So if I somebody put number 4 here, then what will happen here? Okay, so will it be error or something else? So there will be for that there will be one some default case. Okay, you see here, as true false are only two cases, there will be no default case. But when you use numbers, you have many other options, right? So for example, I have defined like 0, 1, 2, and 3 cases myself. But suppose I put 4 here, what will be executing here? Okay. So we have no coding for that. So for that, LabVIEW selects one of the case as a default. Okay. Default means what? If the number selection is not from this range, this particular case will execute anyway. Similarly here is I have enum selected and I have four cases defined and one of them is a default. So this is a very unlikely situation because enums are like predefined list, right? So there will be no other options from there to select. So next structure is called event structure, right? As I mentioned, it takes data from a system and provide as input for our events. Like for example, this events, okay. So you see here, what is written here? It is written as a key down, okay. So whenever somebody press key onto your keyboard, this particular event will be executed. Means whatever the code inside, it will execute here. Okay, so it is called like waiting for user response, and when you get response from user by keyboard or mouse or pressing some button or pressing some boolean value, and you define case for that, means the code inside this structure will not execute until that event occurs. Okay, so for example, there are like 5 components inside this. Okay? So event selector label. So what the code for this assigned to which label is defined by this label here. Okay, and this is like timeout delay for an event. So the structure will wait for some time, okay, for that event to occur. If it does not occur, then it will execute one case which is called timeout case inside this event. Okay, so if nothing happens, no event happens, then whatever the code is inside the timeout case will occur. Okay, so this is called timeout delay, and we define how much time or wait it should wait for the case to happen or event to happen. Okay, usually it is put like -1. Okay, -1 is means like don't wait for timeout, and this is dynamic event terminal. So this is some they are used for event data. I mean, like what kind of data is that, and it can be used to identify which event is happened. Okay, then the event data node where he can, like for example, if user press like enter key, okay, and if you don't assign anything, you don't want to assign any coding for that enter value, you take that enter key and change it to another or discard that key. Okay, means even the user press enter, the code will not register enter. Okay, it will keep doing its work. So like that, you can use these nodes to uh, take responses from user, and you try to make some coding to how you want to process that user input. Okay. So for example, I designed this one. You see here, I put two events. Okay, one is for mouse enter and one is for mouse leave. Okay, and I define like if mouse enter here, mouse enter, you make it turn on. Okay, and if mouse goes out, you turn it off, like that. So I will show you this example, then you will know how it works. Okay. So after that, disable diagram structure, right, in the structure palette. So this is usually used to hide the code from the execution. Means if it is not used and this code is there inside your block diagram, this VI will not run because there is error, right? So if there is error, the arrow will be broken on your VI and the VI will not run, right? So if I want to run the VI anyway, you just draw this diagram onto that error code, and this code will remain inside, but it will not affect your VI to run or not. Okay. So there is two cases here. One is the disabled case. In the disabled case, that whatever is written there, it will not execute when your program is running. Okay? And in enabled case, whatever you put inside that, it will run when your program starts to run. Right? So this is disabled structure. Okay? So structure-wise, these are the different structures we had. Okay? And there is two more variables structures which are available in structure palette. Okay? So those are called global variable and local variable. These are the things we use in program a lot. Okay? This local variables is very useful in our programming. Right? So for example, if you want to create a local variable for this particular control, okay, right click on that, create local variable. Okay, so when you do this, it will happen like this. Okay, so this is called local variable. Okay, so this is a control, but its local variable is here. So as we know before that controls are used to send data out, okay, or input the data. An indicator is receiving the data from the block diagram, right? But when you create a local variable like this, you can enter the data by yourself also, okay, in control also or in indicator also. So even the indicators are meant to read only, you can change it by making use of this local variable on your block diagram. So I will give you example of that. It's like this one. Okay. So this is a control, right? But it is for case 0. Okay. But when I go to case 3, I want to change the value of case 3 now. But I don't want to that extra control. I just want to change its value. Okay. So I put to case 3 as a string constant and I assign to the its local variable. So the even the control is the same, but its value is a change to case 3 now. Yes, before it was question case, and now it has the value of case 3. Okay. So this way you can change the values inside the controls or indicators by using uh, this local variable. Okay. But you should remember that this local variable, as name suggests, it is only available locally in that particular VI. Means if I create a local variable here, okay, I will use it only in that VI, not in another VI. But if you want one variable in three different VIs, you can define some global variable. Okay, so this you can find it here. So local variable is here, and global variable is here. So go to structure and global variable. It will occur like this. Okay. So it is just you see a globe here, but it's a question, means it's not defined yet. Okay. So when you put it on your block diagram, it looks like this. Then you have to define the global variable. Okay. Then you double click on that. It will open one front panel. Okay. So global variable, when you define, you want to define it, just double click it, and it will be open front panel. And this is a special kind of front panel. It has no block diagram. Okay, it has only front panel. Okay, so it has only front panel, and you define some variables here. For example, I define some variable like I use this true value. Okay, so when I define and save this front panel, okay, it will have this option like when it was like before it was having no options. Okay, but when you define it, You click on it and it will show you that some value is there and you can use it to define it. Okay. So when you select that and click on that, it will appear like this. So now it is the one variable which are allows to you read and write as a boolean data. Okay. And this value you can use in a different VIs of your same project. Okay? When you define one project and global variable inside that project, this variable you can use it for every other VIs in your project. Okay? So when you want to use this VI in another VI, means you want to use this global variable into another VI, you use like go to your project explorer and use this global VI. Okay, the name will be some kind of VI, and you just drag it and drop it on your block diagram, and this VI will appear like this one. So this is what we have, and all of these, like the loop structures and data structures, are used in your are the main things. Yeah, so there is one more thing. When you have some VIs structures on your VI, there is a you need to pass the data from outside to the inside the structure, and from inside the structure to outside the structure. Okay. For example, your while loop is running and you want to have data from outside the while loop, and you want to give it outside the while loop also. Okay, so that is called tunneling of your loops. Okay, tunneling, data tunneling in your structure. Okay, so you see when you want to enter the data in your while loop or some true false structure, you will see some boxes like this. Okay, so you want to give some data inside the while loop and you want to do some calculation and you want to put some data outside. Okay? So these boxes will appear into your edges of while. So this is data to go in, this is to data to go out. So these boxes are called tunnels. Okay? So these are the boxes called tunnels, and if only one structure is there, there will be no other things. But this case structure, when you have true or false case, you will have two cases, right? And that time, when you tunnel this data out, there will be this kind of things happening, like empty boxes. Okay, and when these empty boxes appear on your block diagram, it is called error on your. So these are the difference boxes. In the completely filled is called define the data, a tunnel. Okay, so this will not have any errors on your VI, but something like this will give you error. Okay, so these are the error tunnels. So you have to define it. It's like you either give it to like a half filled one. This will avoid the errors on VI, but it's not useful for your applications because it will make the VI to use the default values of that particular data type. Okay, so it's not like a default value. If you want to define some default value for this particular data out, you just define it, and when you define it for both the cases here, this square will become like this. Okay, when it becomes this square becomes like this, there will be no errors on your block diagram. Okay, so this way you can take data from one structure to another structure, and from inside the structure to outside the structure. Okay, so you have to take care of these kind of square blocks. Uh, it should not be edge filled only. It should be either half filled or it should be completely filled. Okay, so when you want to pass in or pass out the data from the structure. Yeah, this one was like for loop, special for loop. Okay, so go by. I look at my mouse. Okay, I will tell you what to look at. Okay, so in for loop, okay, there are different types of tunnels. Okay, so input tunnel will be like this kind of tunnel or this kind of tunnel. Okay, so when you use array, okay, array has a number of points inside the loop. Okay, inside the table. And if you want to access each point of that table, you use this indexing. It is called indexing. Okay, uh, here this is called indexing. Okay, you see here. So when you supply this array to these loops, you can assign this as indexing or not indexing. Okay, when you index it, the array will be like stop here, and one by one the elements will pass inside the iteration. Okay, so means for first cycle it will read zeroth element. Okay, then second cycle it will be first, then second, then third, then fourth. Okay, so this is called indexing of data. Okay, so when you enable this, the data will not go as array, but it will go as element of that array. Okay? So one by one, it will pass to the loop. Okay? And when you don't want that, like you want to use all the array inside the loop, you just pass it directly. You right click on here and just disable indexing. All the array will pass through this while. Okay? So this is called disabling the indexing. Okay? So when you have like this one unindexed in, it can be array or single value. Okay, you can supply this as single value or you can supply as array to the unindexed input. Okay, so when you make it indexed by using this one enable indexing, array you can pass array to this indexing. Okay, and then this for loop will choose one of element for each cycle and then calculate and go for next cycle it will choose the next element. Okay, so this way you will have like automatically selecting one element for your calculation and do calculation, and for the next cycle you do the same calculation but for next element. Okay, so that is the property of array, and which you can use in the for loop or in a while loop by enabling this indexing. Okay, so when you do this data, when you output this as a indexed output. Okay, when you do indexed output, you will have option like tunneling mode. You can say set as a last value or indexing value concatenate. So what it does, like last value will be like it will be do all the calculation and it will take only last value out. Okay, it will give you last value of your all the calculation. And when you do indexing, okay, it will be some, if one element is passing to this and if you enable the indexing, it will give you out as array. Okay, means it will create automatically array and give it out. Okay, and which you can use for further processing. Okay? And third one is like concatenating. This will make what happens, like you pass the array and when it outputs, like it will append the array in each cycle. Yes, it will take one array when it goes to uh, complete one loop, it will return back with the connected joined together. So it will be like adding array to array every time. Okay, and this will give auto concatenating properties for this. Okay, so it will make array longer arrays means in multiple of the array sizes. Okay, so these are the different types of indexing tunneling mode. Okay, it will be useful for making data in array or accessing the data in array or modifying the data in arrays. Okay, and the next one is called the shift registers. Okay, this is useful to have the data from. It is useful when you want to store data of previous loop. Okay, so you want to know what happened after this loop, you use this shift register. Okay, when this calculation is finished, this data will go back here. Okay, and it will start okay, this data will not stop here but it will go back here and do the calculation. Okay, so this is called getting the data of previous loop and use it for next calculation. Okay, so this is for this we use shift register, right? So for example, okay, so these are the shift register of single data. Okay, so then there is another option which is called stacking of shift register. So here what happens, like when you finish the cycle, okay, this data will go here, okay, on the first loop, and this will pass here. But before that loop, what happened? It is stored here. Okay? So this is called stacking of the data. Means this data here is like two loops before. This is one loop before, and this is for this loop. Okay. So this way you can increase the number of the stacking here, and you can have like four loops before data, or five loops before data, or six loops before data. Okay. So this is the way by which you can have that the numbers of data from the previous loops. Okay, and the other way of having the same functionality is using the feedback nodes. Okay, inside the loop. Means if you see this one and this one, it is doing the same thing. Okay, so this shift register doing like data going from here to here and processing here and again doing the same cycle. Here also same happens. Like here you define the default value here and then it start calculating, okay, and then it goes back here. So this is we use this feedback node we use when we don't want to make that long wire on your block diagram. Okay, these are the long wire, and you can achieve the same functionality by using this feedback node here. Okay, so this is how we use the structures and loops, and we can allow the data to pass in and data to take out of the loop and structures. Okay. Yeah. So loop tunnels and structures and data types we finished. Okay. So please use a tunnel vision when you want to use the data in your structures. Okay.